Hello Earth Science students, welcome to the extra credit homework review session. Please look at instructions under the assignment to see how to gain your extra credit for tomorrow's quiz. So I just wanted to take some time to go over some of the answers to the questions for the first assignment that was due. A lot of these questions will look similar to your quiz questions tomorrow. So looking at 1, 2, and 3, please add on in the comments if you feel like I didn't go over a certain question that you wanted me to go over. But out of these 3 questions, I'll take a second to go over number 2 and 3. So for number 2, here goes the map in question. And number 2 says, which sediment would usually be deposited by the stream first? Well, for this question, you mainly need ESRT, page 6, this chart right here. This gives you the sizes of all the sediments. And another piece of information you would need to know is that the heaviest, largest, most densest, and roundest sediments are the ones that tend to deposit first. So this question's talking about size, and here size also relates to their heaviness. So out of these choices, the heaviest one that will be deposited first is pebbles. Looking at number 3, with which landscape feature would this meandering stream most likely be associated? Well, meandering streams have flows that are wavy and not perfectly straight. If this stream were to form on the side of a mountain, it would be straight, as gravity is going to want to pull it just towards one direction. It wouldn't have time to sway side to side because gravity wants everything to just go down. So this type of formation, meandering stream, would need to form in a plains area that's gently sloping. So there goes number 3. Okay, number 4. This deals with the inside and the outside of the elbow. We saw the example with the water slides. Water slide engineers put that extra little piece of slide there, the little lip there, to help people from not falling out due to a faster velocity on the outside of the elbow. The inside of the elbow has a slower velocity. So the answer is C, and let's see why. Go up to the question here. So this would be considered the outside of the elbow. That's where a water park engineer might put that little piece there. And here goes the inside of the elbow. You actually get more erosion here because the water moves faster, and you get more deposition here, meaning particles get dropped off because around A, that's where the water moves slower. So really what you get here is a sandbar. Over time, you get more particles added to this side, and over time, this is a cut bank, more particles are taken away from this side. So the meandering stream kind of gets exaggerated as it flows over time. So question 5 is talking about the side view. So if you think about what the side or the profile would look like if you were kind of like under this stream and you had your goggles on and you were looking from the side, like let's say you were, well, they're asking about ABC. So let's say you were like right here under the water and you had goggles on and you could see the shape that the stream makes side to side. So since, sorry I drew so much over this, but since there's more deposition here on this side by A, and there's more erosion here on this side by C, what you end up getting is a cliff-like feature on the C side and more of like a sand or beach, like where you could kind of walk up to it easier on the A side. So you need to just make sure that the deposition side has this kind of slope, and the erosion side is much steeper. any questions about these notes, please put them in the comments. Some of these terms. So siltation deals with, as rivers flowing, particles continue to bounce across and bounce against one another. That breaks them down over time. Rolling helps give the particles their round shape as they roll down the river. Suspension, usually smaller particles like clay or silt, are kind of floating around. They don't settle to the bottom, so that's called in suspension. Glaciers form U-shaped valleys. Streams and rivers form V-shaped valleys. That comes up a lot. So a glacier valley might look wider, more like this. River valley might be more V-shaped. So that's what the Grand Canyon looks like. It has a V shape, whereas the Hudson River, because it was carved out by a glacier, has more of a U shape. These tend to be much wider. Agents of erosion, we have wave action, wind, especially in arid climates. Gravity, always pulling towards the center of Earth. So as soon as a crack forms on a mountainside, it could be a rock fall. And when rocks are newly fallen off of mountainsides, they have jagged or angular edges. You can tell if they've been moving in a river because they'll have rounder edges. Okay, so if these are made of the same material, have the same mass, which one will settle fastest? So it's going to be rounder, since they all have the same mass and the same density. Out of these four shapes, the roundest shape, this is also round too, but that's roundest, so that roundest shape would settle the fastest. It just cuts through the water more easily as it falls down. So if a stream is flowing and then its velocity decreases, the one that'll settle to the bottom first would be the one that's roundest and densest. And out of these choices, that will be W, roundest and densest. In this case here, which mineral sample would settle slowly? So in this case, they're asking which one will take the longest to settle, and it'll be the one with the lowest density. So quartz is the lowest density in this example. So here we see most of the colored in particles are at the bottom, and most of the not colored in particles are at the top. And this looks very much like a density tower because it is. So we could assume the particles that are at the bottom must be more dense than the particles that are up top. So the question says, the pattern indicated that compared to the particles of sediment B, particles A, which are the shaded in ones, are greater density. Particles of sediment A have a greater density. Okay, so let's see. Do we have to do everyone here? Which particle would usually settle most rapidly? Very similar to the other questions. Will be the one that is roundest and most dense. So that would be D in this case. Again, any comments of questions that you want explained further, I could type out a further explanation in the comments. Okay, so this is an interesting question. What caused this specific pattern? Well, if we look at the shapes, all these particles are similar shapes. What's different about them is their size. So I definitely put the wrong answer here. Which characteristic of the sedimentary particles most likely caused the pattern of deposition shown in diagram 2? So yeah, like I said, now it is actually particle size that's different, not D. The answer is B. Everything else is the same. However, since these are bigger, that makes them heavier, and they'll fall to the bottom. At which point will most deposition occur? Well, deposition happens when streams enter deltas, or where they enter lakes, I should say, and form a delta. And oh, look, what a coincidence. D is where the delta would form, and that happens to be the answer, and that's also where deposition happens. So D, deposition, delta. They slow down. When the rivers slow down, they drop off bigger particles. Okay, so this is called horizontal sorting, and horizontal sorting actually has the same premise. The premise is that the heavier, larger particles stop first, but since it's happening horizontally, the pattern looks a little bit different. So in vertical sorting, if you remember, so this would be vertical sorting, you have the bigger particles, then they get smaller. So bigger at the bottom, smaller on top. Horizontal, the bigger particles, heavier particles are here, and then the smaller are down there. Okay, so how is this pattern of horizontal sorting produced? How is this pattern of horizontal sorting produced? Well, in this model, we have the bigger particles that generally deposit first because the river's coming from this way. Silt and clay particles might float and be in suspension a little bit before they finally settle. So that's why you get the bigger particles, boulders, cobbles here, and it gets smaller as you go along. And again, you need to look at these sizes here, and that relates to page 6 of the ESRT. That goes to question 9. The sedimentary rock siltstone will most likely form from sediments deposited in zone. So you need to know what type of particles make up siltstone. This one is easy because it tells you in its title, but not all of them are easy. So let's look at the rock page. All right, so here it says siltstone is made from silt. However, if you see the rock shale, it's not so easy to figure out that shale is made from clay. So you definitely have to check here. Sandstone is easy because it tells you it's made from sand. However, these two, you need to definitely check. So conglomerate, that word just means put together by a lot of pieces. So conglomerate rock and then breccia rock. These two are very similar. However, conglomerate rock are pieces of rock that have been through rivers. You can see by their rounder edges coming together and making a sedimentary rock, whereas breccia are more of the mountain cliff rocks that fall off with sharp edges and have not gone through a river coming together and forming a sedimentary rock. So the map zip symbols usually represent a lot about the rock too. Okay, so if we look at C says 0.0004 to 0.006. We'll go over here, and that range 0.004 to 0.006. I might have said that one wrong, sorry. 0.0004 to 0.006. That would be silt. See, earth science is not that bad. You just got to know how to use the ESRT. So siltstone would be in zone C. All right, so they say here somebody picked up a particle that was 0.4 centimeters in diameter. So which location most likely did they collect that particle from? Okay, so similarly, come here, find out which one is 0.4. So that's 0.2, so it must be above that. That's 6.4, so that's too much. So 0.4 will fall in here, it'll be a pebble, as I noted here. So A, that's where the pebbles are. All right, so this picture here is, vertical sorting. So we'll have the largest particles at the bottom, medium size in the middle, and smallest on top. That's how you get that when the velocity decreases within a steady lake. All right, I know a lot of people weren't able to do this one, but it's good to know. So we see the bigger particles here, medium-sized particles here, smaller particles here. They're asking which direction did this delta form, which direction did the river flow? It flowed this way because the bigger particles get dropped off first, then the medium, and then the smallest particles. All right, so for the short answer questions, briefly explain why deposition of sediments usually occurs where streams enter a lake. The deposition of sediments usually occurs where the stream enters a lake because the velocity slows down, therefore it can no longer carry bigger sediments. Good, thank you. This is a student example, it's a good, correct answer. Name the type of sediment most likely represented by letter X. Well, X is after silt, and if you look at the chart, clay is after silt. Explain how stream velocity is related to the erosion and deposition of This was a very good answer. And I'm expecting more full answers, more complete sentences from students. I didn't take much points off this time. However, I need more complete sentences. I'll give you more guidelines around that in future assignments. The stream's velocity is related to the erosion and deposition of sediments by particle size, since whether the velocity is fast or slow determines where the sediment will be deposited. For example, if the velocity slows down, the water would no longer push the boulder, so it would be released and dropped off into the lake or that type of water. However, silt could still continue to be pushed and continue in the stream since it's smaller and the current can still carry it, unlike the bigger sediments. Exactly. As the stream slows down, more deposition occurs, and as the stream speeds up, more erosion occurs. And there's a guide to see what gets dropped off first, second, and third, and that would be this right here. So it lets you know how fast the stream has to be moving in order to pick up, erode, or drop off deposit sediments. And these are the sediments here. Just to quickly go over this homework assignment, there was one question, number 6. Reference table. If a stream has its velocity reduced from 1 centimeter per second to 0.1 centimeter per second, what particles would get deposited? So this question is first asking you to figure out how much is moving at 1 centimeter per second. And then think about, once it slows down, how much of that which was already moving is now dropped off. So going over here, 1 centimeter per second, that means that stream could pick up some sand particles, silt particles, and clay particles. Now, if it's reduced to 0.1, it's only silt and clay. So therefore, it would drop off sand. You could also say more specifically, it would drop off some sand particles and some silt particles, because if you look at 0.1, that doesn't go all the way up to these big silt particles. It's only somewhere in the middle here. So just remember that as the stream slows down, not everything's getting dropped off, only the things that cannot be supported by the velocity of the stream. What may lead, sorry, I think I made an error there. What may lead to the conditions of chemical weathering? That happens when animals and plants are decomposing. That happens in more humid climates. That happens when oxidation happens, when iron and copper are exposed to water or high oxygen levels. That would lead to more chemical weathering. All right, guys, thank you for tuning into the homework review. I know it's 20 minutes, but you could zoom back and forth to the parts you need. Please look at the instructions to see how to get your extra credit. Thank you.